Hi everyone, in this video we are going to practice balancing nuclear equations. So I have 8 different problems for you in this video, and so I hope you go through each one of them, but just so you know they get progressively more challenging, so if these first ones are really easy for you, just zip to the end of the video and try 7 and 8 and make sure you can do both of those. So let's start off with a simple one, simple-ish. So what I want you to do here is to fill in this box or fill in this blank. So a correct answer would have 3 components. It would have a superscript, which is your mass number, a subscript, which is your atomic number, and then the big symbol itself, so the actual element. So go ahead and give this one a try. All right, did you get an answer? Hopefully you did, but if you didn't, don't get frustrated. We'll work through this together. So what we need to do first is realize that we're trying to come up with 3 different things. So we have a mass number, we have an atomic number, and we have the actual element itself. So there's 3 different components we're solving for here. So we're going to start off with the superscript or the mass number. And so we remember that our product side and our reactant side have to total to give the exact same number. So let's start off with a reactant. There's only one reactant, and that's what we're solving for. So we're going to say A is equal to, and then it must be equal to the superscripts of every single product total, the sum of them on the product side. So for this one, we're going to take 14 and add it to 0. Pretty straightforward. This number has to be 14. So that was easy. We just solved for A. We know what the mass number is of our unknown. Now we can try to solve for our atomic number. Same thing as with our superscript. Our subscripts, the sums have to be equal to each other on both the reactant and the product side. So since we only have one reactant, we're just going to say B is equal to, and then we have to add that to the subscripts on the product side. So our product side has nitrogen, which has an atomic number of 7, and then we have a beta particle, which has an atomic number of -1. So 7 minus 1 gives us a value of 6. So right now we're looking at something that is a 14 superscript, a 6 subscript, and now we're trying to determine Z, which is actually the element symbol or the name. And the easiest way to do that is just by looking at B, or what we call our atomic number. So this is telling us that whatever nucleus we're talking about has 6 protons. So all you have to do is go to your periodic table and look at it and say, okay, what is the only element that has 6 protons? And the only one that has that is carbon. And so this has an element symbol of a big capital C. So the proper answer here would be 14,6C, or carbon 14. Let's try another one. So for this example, we're looking at trying to solve for a product instead of a reactant. Go. All right, did you get an answer? Hopefully this one was a little bit easier after going through the first one together. So just like before, we have 3 components we're solving for. We have A, B, and Z. So let's start with A, or our mass number. Now remember, our A has to have our reactant and our product side equal to each other. So if we remember what we did on the first one is we set A equal to everything, but we can't do that on this problem because A is actually part of a product and there's 2 products. So what we're going to do for this one is say 234 is equal to A plus 0. So 234 is equal to A plus 0. We're just adding up all the superscripts. The math is pretty simple for this one. So the only thing that A could be equal to mathematically is 234. So that's pretty easy, 234. That's our superscript. Next one, we're going to do the exact same thing but with our subscripts. So now for this one, we're going to take our reactant, which has an atomic number of 90. We're going to set it equal to B plus a -1. So just like with the previous example, we're going to solve for our B again. We have to add this -1 component, so there's actually a little bit of subtraction involved. But in order to do this properly, the only way you could solve this mathematically is for B to have an answer of 91, or an atomic number of 91. All right, so our subscript has to be 91. Now the last thing we have to do is solve for our element. Again, B tells you what your element is. So you're going to look at your periodic table and say, which one of my elements has 91 protons? And the only one that has 91 protons is called protactinium. So it's a beautiful, beautiful element name, but the symbol is Pa. And so to do this properly, all you would have to do is come up with this answer here. So protactinium 234 is the correct answer. Let's try something that might be a little bit more challenging, but maybe not. Depends on if you're understanding this. So go. All right, did you get an answer? Hopefully you did. This was just like that very first problem we did on this video. And so all we're doing, just like before, is we're solving for A, B, and Z. I'm going to fly through this a little bit faster now just because we're used to it. So A is our superscript. That's our mass number. We have our reactant side. We're setting it equal to our product side. So A has to be equal to 131 plus 0. The only answer possible is 131. Pretty simple. 131 is our superscript or our mass number for our answer. Now we're going to look at B. B must be equal to 54 plus a negative 1. So similar to before, we're having that subtraction problem. Ooh, hard math, right? So we have 54 minus 1. The only answer we could possibly have for B is 53. So we have 53 here for our subscript or our atomic number. Now we're just trying to figure out what the actual element is, or our nuclei in this example. And so for Z, we're looking for our B, or our atomic number, which is 53, because that's going to tell us what our actual element is. So we're looking for an element that has 53 protons. And if you look at your periodic table, the only element that has 53 protons is iodine. So our answer would be iodine 131, or 131I with 53 for our atomic number. Okay? All right, so now we're moving on to one that's a little bit trickier. And depending on what section you are in on the course material right now, you may or may not be able to solve this. So just do your best, come up with the answers, and then come back to me and we'll talk through it. Go. Were you able to get the answer? Hopefully you were. I really, really hope that you were, but maybe this was something that was a little odd for you, so please don't get frustrated if that was you. All right, so same thing as before. We're looking for a mass number, an atomic number, and an elemental symbol. So let's start with the easy one, the superscript. For this one, we have 0 plus 0 is equal to A. So that's really, really hard math. A is definitely equal to 0. We have a mass number of 0. Now let's look at the bottom one. Negative 1. Negative 1 plus 1 is going to be equal to B. So negative 1 plus 1, really hard math, definitely equal to 0. So now we have a superscript and a subscript equal to 0. The only thing that could possibly have 0 for the atomic number and 0 for the mass number is what's called a gamma particle. So the correct answer for this is definitely a gamma particle. If you ever see 0 and 0, you know that it has to be gamma. There's 0 elements out there that do not have a proton in their nucleus, okay? Every single element has to have a proton in its nucleus. Otherwise, we're talking about some crazy type of particle, for example, a gamma particle. So hopefully that makes sense. All right, so now we're going to kind of switch it up a little bit. We're going to change the way these questions are asked. So now I'm going to give you more wording and some different pieces, and I expect you to translate it. So what you're going to have to do is figure out what the symbol is for this, figure out what the symbol is for this, and then you're going to be able to actually solve for your product. Take some time, work through it. All right, did you get an answer? Hopefully you did, but this was definitely trickier, so don't get frustrated. So what we have to do here is translate this word notation into something fancier, or into some kind of symbol. So we know it's arsenic. Arsenic has the elemental symbol of AS, and we know that it has a mass number of 73. So whenever you see the name and then the number is the mass number. Now, we have the element. We know it's arsenic, so all you have to do is look at the periodic table, find the periodic table, find arsenic on the periodic table, and then you can determine the atomic number. So arsenic has an atomic number of 33, so I'm just going to write that in there. Now what we have to do is add an electron to it. So this is something you just have to have memorized. An electron always has the exact same symbol. It has a mass number of 0 and an atomic number of -1. That is always what an electron is going to look like, so just get that down. That's something you just have to memorize. All right, now it's the same as before, as in questions 1 through 4. We're just trying to fill this in and actually solve for our product. So it's the same thing as before. We have to look at our superscripts. 73 plus 0 is going to give us A. In this case, A has to be 73. There's no other way around that. All right, so then our subscripts, or our atomic numbers, is going to be 33 plus a -1, again, hard math, that's going to be equal to B. So 33 minus 1 gives us 32. So now what we need to do is figure out what element has 32 protons. And if you look at your periodic table, you will be able to see that that is in fact germanium. So the correct answer for this one was germanium 73. So hopefully you were able to get that. Let's try another one. Go. All right, did you get an answer? This one was just a little bit trickier because you had to find 2 different pieces of information off the periodic table. So let's start with polonium. Polonium has the symbol of PO, and then it's telling us that it has a mass number of 210. So what you have to do is go to the periodic table and figure out how many protons polonium has, and it actually has an atomic number of 84. So then we're going to move on. We need to set up the second part of our equation, which is the lead component. Lead has the symbol of PB. 206 is the mass number, so we just write that right there. Now we have to go back to the periodic table one last time for this part, and figure out how many protons lead has. If you do this properly, you'd be able to see that lead actually has an atomic number of 82. Now we're actually solving the part of the problem. We're ready to solve it. So what we need to do is start with our mass number, our superscript. We're looking for A. So 210 is equal to 206 plus A. The only thing that A can be equal to is 4, right? 210 minus 206 definitely gives us 4. So we have a 4 right here for our mass number. Now, right away you should be thinking, ooh, I bet I know what that is. Okay, that's one way to kind of just have those little red flags go off. 4 is something that's very unique, and so we'll get to that in just a second. All right, so now we're going to look and see if we can solve for our atomic number, or B. And so we have 84 is equal to 82 plus B. The only way you can solve this is for B to be equal to 2. So 82 plus 2 definitely gives us 84. So now we have 4, we have 2. This is definitely what we would call helium, but we would also refer to this as an alpha particle. So if you ever see 4 at the top, you should be immediately thinking, is this an alpha particle? Is this an alpha particle? And see what you can do to solve for that, okay? Hopefully this one makes sense. We're going to try one more that's a little bit harder, just slightly harder. I don't know, maybe it's easier. Try it. Go. All right, did you get an answer? Just like before, we have to figure out what our actual nuclear equation is first before we can solve for our missing reactant. All right, so we've got our missing reactant. That's what we're looking for. We're going to add that to an electron or a beta particle. So this beta particle is always going to have the symbol of 0, -1. Remember, that's your beta particle. Again, if you're not to this part yet in the lecture material, just kind of ignore this, and when you get there, come back and review the video. All right, so now we are adding it to a beta particle, and then we're going to produce gold 201. Gold has the symbol of Au. 201 is the mass number, so that becomes the superscript. And now we just have to go to the periodic table and find gold and figure out how many protons it has. Gold actually has an atomic number of 79. All right, so now we're ready to solve the problem. We're looking for our missing reactant. So I'm going to get rid of that right there just to clean it up. So let's start off by looking for our mass number, or our superscript. So A plus 0 has to be equal to 201. Again, very, very difficult. It has to be 201. A has to be equal to 201 in order for that to be mathematically true. So now we have to look for B, which would be our subscript, or our atomic number. So B plus a -1 must be equal to 79. Well, the only way mathematically we can solve for this is for B to be equal to 80. So 80 minus 1 gives us 79. We've solved this correctly. So our atomic number is 80. Now all we have to do is go to the periodic table and figure out which element has 80 protons in its nucleus. And the only one that has 80 protons in its nucleus is mercury, which has the symbol of Hg. Okay. Now, we have one more problem. If you can do this last problem, I'm going to feel very, very confident that you understand this material. So let's see if we can get through number 8. Go. All right, did you get the right answer? Oh, I hope you did. I really hope you did. I want you to understand this so badly. But what you see here is I've kind of been a little bit sneaky, and I've left off part of the information. And so in this nuclear equation, I did not provide you with the atomic numbers. Now, does that mean you can't solve this? No, absolutely not. It just means you have to put a little bit more work in order to actually solve this problem. So the first thing you need to do is go to the periodic table and find each one of these 3 elements. And you need to figure out what the atomic number is. So right away, I look at helium-4 and think, I know that has to be 2. This is definitely an alpha particle. So personally, I don't even have to look at the periodic table for that one. I want that to be where you're at eventually, but you just might not be there. Now we need to figure out what aluminum is. Aluminum actually has an atomic number of 13, and phosphorus actually has an atomic number of 15. So again, these are things you would find directly off the periodic table. All right, now we are ready to actually solve for our problem and solve for our missing unknown, or our missing product. So let's start with our superscript, our mass number. What we have here is 27 plus 4 is equal to 30 plus A. Whew, we finally have some math that's a little bit challenging here. I think we can figure it out though. 27 plus 4 is definitely 31. 31 is equal to 30 plus A. The only thing A could be equal to is a +1. So we're going to put a 1 right there up as the mass number. All right, second one. For our subscript, or our atomic number, we have 13 plus 2 is equal to 15 plus B. So we're looking for our missing atomic number. So B would be equal to, let's see here, 13 plus 2 is definitely 15, which is equal to 15 on the other side. The only thing B could be equal to is 0. So we have 1, we have 0. Right away you should be thinking, okay, this is one of those particles I need to know, and this is called a neutron. You absolutely need to know what a neutron looks like. It's a 0 with a 1, little n symbol, and that's what a neutron is. Hopefully you feel a little bit better about balancing nuclear equations after going through this video. If you don't, please take some time and just practice, practice, practice. That's all it is. The more time you put into this, the more it will make sense, and the easier it will be when the time comes for you to do it on the exam. Good luck. Take care of yourself. Drink water.